Hello guys, welcome back to another video. Now, is this Mini Cooper S engine savable? Before we get into things today, make sure you hit that like button. It really does help me out and it is greatly appreciated. Now then, you will see on the previous video where I completely stripped down this entire engine. Now I have actually went a step further and completely disassembled the head as well. So I've removed all of the valves, the valve springs, and gave it a good clean up. This is pretty much ready for reassembly now. The same goes with the block as well. My dad has actually sandblasted the outside of the block, so that is looking a bit nicer now as well. Now the thing that you're probably most interested in is what's the damage with this engine. So pretty much the only damage with this engine is this right here. Just this one exhaust valve. As you can see, it is, not quite complete, is it? So I don't know if this, slowly burned away over time, or if a chunk of this, just broke off and flew out the exhaust. No idea, but I have inspected the exhaust, I've inspected the turbo, and I can see no signs of any damage. But yeah, as you saw in the removal of the cylinder head, we saw that we had one bad exhaust valve. So in theory, once we removed the head, we really didn't need to go any further. We could have just kept the bottom end as it was, kept the pistons in, kept the rods in, and still had all of the original bearings. But I wanted to go a step further. As I mentioned right from the start, the plan was going to be a full engine rebuild. I've never done one before, and with these N14 engines being notoriously bad for a whole host of different problems, I wanted to give this engine a new lease of life and the best possible chance going forward. So yeah, that is still the plan. We are still doing a full engine rebuild. Now you're probably wondering, what kind of shape are things in? Like the cylinders, is there any wear to them? The crankshaft, is there any wear to that? And the pistons as well, is there any wear to those? And I actually have some measurements right here. So my dad is a mechanical engineer by trade, and he has actually taken the block and the head to his work, and he has had them on a machine. I don't really know the ins and outs of it, but he has had them on a machine, and he has measured I believe it is the block face where it meets with the head, and also the head face as well. Now I don't know what it is, but for whatever reason there seems to be a craze where people remove the cylinder head and they automatically get it skimmed. No idea why this is. You only need to get a cylinder head skimmed if there is some some warpage, or if there's some deviation in the head itself. Now I believe in the Haynes manual, I believe it does have the tolerances in here, what it does allow you to have. Let's have a look. So cylinder head maximum gasket face distortion 0.05 millimeters, which is 50 microns. So that means that if you measure I guess across the cylinder head face and across the block, that you can have a maximum of 50 microns deviation. And when my dad measured it, it came out at 0.026, which is 26 microns. So that is only half of the the tolerance basically. So we're well within the tolerance. Now if you was to get your head skimmed, I believe they take off 0.3 millimeters, which is I know it's 300 microns. So yeah, they take off quite a bit. So this is just a bit of advice. You don't need to get your head skimmed unless there is like I said, a massive deviation with the surface. I know it makes the head look nice, but you really don't need to do it. It's actually considered a bad thing, because if you are, you know, taking some material off of your head or the block even, then you are actually going to alter the compression ratio. Now it may not be by much, but you are still altering it, because you are making the combustion chamber smaller essentially. So yeah, the cylinder head and the block face are absolutely fine. Now when it comes to the cylinders, the major thing that we was concerned with is, you know, are the cylinders fine? Are they going to need reboring? Are we going to need oversized pistons, oversized piston rings? So from factory, they should come, the cylinders, they should be 77 millimeters exactly, bang on. Now, how accurate that is, no idea. But again, we do have the tolerances in the Haynes manual. And so, I'm not too sure which way around this is, but I'm just going to go. Cylinder 1 is 77.0. Okay, I'm going to stop myself right here. So we have two measurements. So of course it's good to have two measurements, one at the top of the cylinder and then one kind of in the middle. So we have at the top of the cylinder and then one 50 millimeters down as well. So cylinder 1 at the top, 77.039. So that means it has worn 39 microns, which is, you know, within spec. That's next to nothing. Cylinder 2, again, 39 microns, so 77.039. Cylinder 3, 35 microns. Cylinder 4, 37 microns. Now, if we go down 50 millimeters, so bear in mind you're going to get most of the wear at the top, because that's when the pistons kind of rotate and that's when they're going to make the most contact with the cylinders. So yeah, again, cylinder 1, so 50 millimeters down, we're looking at 31 microns of wear. Cylinder 2, 32 microns of wear. Cylinder 3, 30 microns of wear. And cylinder 4, 24 microns of wear. Now let me just check the specs. So when it comes to the cylinders, so yeah, here we go then. Cylinder bore diameter 77.00 millimeters nominal. So yeah, like I said, they have all only worn a maximum of 39 microns, which is absolutely nothing. So yeah, all of the cylinders are fine. They are obviously going to require rehoning, but we don't need to do a rebore or anything like that. Usually if you do a rebore, you're talking like either 0.25 or 0.50 millimeters, which is 250 or 500 microns. And like I said, at the most we've only worn 39 microns. So that's like, you know, like just slightly more than 10% of what you would, rehone. So yeah, well within tolerance, no issues with that at all. Now then, the crankshaft. So I do have a micrometer. Well, I actually have two. I have a bigger one and a smaller one. The smaller one I use to check the measurements on the valves. So the valves, exhaust valve, I've got all 8 brand new exhaust valves. I'll show you them in just a little moment, but obviously they're fine, they are brand new. The intake valves, again, they are all within spec, no issues with those. And for the crankshaft, the main bearing journal diameter for the petrol engines is 44.984 to 45 millimeters. This was within spec, and for the big end journals, it was 40.975 to 40.991. Again, this was within spec. So yeah, crankshaft again is absolutely fine. Okay, and so now that we know that both the head and the block are fine, let's have a look at everything else. So we have pretty much the cylinder head all laid out right here in front of us. So we have the existing intake valves. I've gave them a good clean up. They're looking perfect now. Again, the springs and the spring hats have all been cleaned up as well. We have all of the original rockers and tappets and collets, again, they've all been cleaned up, all in their original locations. The camshafts themselves, no wear on those at all. All of the lobes are absolutely fine. I just gave them a quick clean up as well. We have new piston rings to go on the end of those as well. They actually sit on the end here for the variable valve timing gear. I believe these are to maintain oil pressure. So I thought it'd just be well enough to buy new ones of these. If you're wondering what the originals look like, it is these. These, I guess, are the older style ones. Of course, like I mentioned, we have all new exhaust valves. These, of course, will need to be recut. Oh, and by the way, I will be relapping and reseating all of the valves, not just the new exhaust valves. They are actually not in bad shape, the original intake valves. I can't really see any pitting on them, but it's just as well to reseat them into the head. It's just good practice. Now let's move on to the crankshaft. So of course we have all new bearings, so new big end bearings, new main bearings, new thrust washers, of course new piston rings, new rod bolts, new main bearing bolts, and those are those blind plugs for the two hidden main bearing bolts. Now I'll just show you what the pistons now look like. As you can see, I gave them a thorough cleaning up, removed all of the original piston rings. These are looking quite nice, but again, all ready to go back into the block. And then with everything else, that is a bit of a mess. So this is pretty much all of the ancillaries. So we have the intake manifold, we have the drive shafts, a lot of these vacuum hoses that I am going to be completely replacing. Things like these tensioners, that's all being replaced with brand new parts. They are on the way, I believe. And let's move over to here. So the original oil pump, that's being replaced for a brand new one, along with the high pressure fuel pump. We have a new one of those. Things like the Vanos solenoid, the Vanos gear, again we are replacing that all for new. Again with the vacuum pump, of course drive bats, you're always going to replace a drive bat, aren't you? And tensioner as well. Everything pretty much is being replaced for brand new. I want this engine to both perform and look like a brand new engine. And just moving up onto this shelf, so we have, of course, the starter motor, the AC compressor, turbo, exhaust manifold, that's all been cleaned up. The oil filter housing, that has all been cleaned up. That has actually been sandblasted as well and all cleaned out. And then we just have just a bunch of parts back there. This is going to be fun when it comes to reassembly. Moving up as well, we just have a bunch more parts. So again, it's going to be fun when it comes to reassembly. I just thought I'd show you the gearbox as well. I gave that a bit of a clean up, haven't went too crazy with it, but of course we have new flywheel, new clutch kit, new fork, new slave cylinder, new input shaft bush, new output shaft seals, and new plugs as well for the fill and drain plugs. But that of course will all be coming once the engine has been reassembled. Okay then, so things were definitely not as bad as I originally anticipated. So the bottom end, the block, the pistons, the rods, they're all absolutely fine. I originally anticipated to have to get the block rebored, and have to get oversized pistons, oversized piston rings, and maybe having to buy new rods as well. But it's definitely not the case. All well within tolerance, and it all looks absolutely fine as well. With regards to the head, really nothing wrong with it either. Only thing is, this burnt exhaust valve, which is a very, very common issue on these N14 engines. It's pretty much all down to the carbon buildup, you know, from the crankcase ventilation system. The fact that it is a direct injection engine means that there is no fuel flowing over the valves and they can't get clean. So yeah, it's one of those things that, you know, you are either just going to have to live with, or you're going to have to periodically clean your intake valves, you know, by way of a walnut blast, or you can just get an oil catch can and you don't have to worry about these issues altogether. But yeah, that's where we are with it anyway. I thought I would update you guys. I'm sure you were itching to know, you know, what kind of state the engine was in. You know, is it savable? We now know that it is. So yeah, I think I'm going to wrap this one up. Hopefully you guys have enjoyed it. Please give it a like, leave a comment down below, subscribe if you have not already done so, and I will see you all in that next one. Peace.